important in making dentures, removable dentures. This is a classical one. You see the base here. We sit the table on it, and on the table we fix the model. This is a horizontal arm placed on a post. And other types of parallelometers, this is articulated and the movement is more elaborate in this case. So the table can be displaced. At the end of this arm, we have the vertical axis that can be moved up and down and can be blocked. At the tip of it, there is a system to fix the accessories. So this is one of them. You just pass it through and you fix it in position. So the tip of the vertical axis. The table now. On this table sits the model that we want to analyze. There's a system to hold the model in place. And this is fixing the model, making it stay in only one position, retaining it. So the characteristic of this table is that it has a ball-like attachment. The ball can move, as you can see, pivot actually, and you can fix it in a certain position. Actually, that position will be the insertion axis in relationship to the vertical axis of the parallelometer, right? So now the accessories. This is the detecting bar. It's cylindrical. We do analysis with it. 4 millimeters or less. You see, there's two types there. Another one is the graphite bar that you can that is like a pencil tip. The third one is the retentivometer, the undercut meter. You see, there's a cylindric part, and at the tip of it, you have a disc, a small disc. The distance between the cylinder and the margin of the disc is increasing in dimension. You see, this is bigger. One was 0.25, the other one is 0.5 millimeters. And on the right hand, yeah, that was 0.5. And this is 0.75, okay? Those values, again, are the distance between the cylinder part and the margin of the disc. The overjet of the disc beyond the cylinder of the instrument. And the fourth type of instrument is the blade bar. It's like a spatula, like a scalpel. It can remove the wax from the model, should we want to do that. So now how we work with it, what we can do with it. So first thing is to determine how we insert or disinsert and disinsert the denture. So what we use here is the detecting bar or the analysis one. The same thing. You can call it both ways. So this is now moving. So you don't know how to fix it. You have to decide what is the right position. So using this, you can check where you have undercuts. And you place the model in such a way in which so as to have the best undercuts and symmetrical front to back, left to right. So we'll have clasps on 1/7, 1/4, and 2/5. This is what is important for us, right? So we lower this bar, connect it to the vertical axis, and we bring the tooth in contact with this bar. And you see, the contact is on the equator. This is the prosthetic equator. And we want to see a little bit of undercut under that contact point. How much undercut? Well, that's the problem. We have to make it symmetrical left to right. Okay? It's a triangular shaped space, which we call undercut. That goes under the contact where the bar touches the tooth. Under it. Okay? In the direction of the gum, of the cervical part of the tooth. So there is where we'll be able to place the clasp. Because if we don't have this undercut, then the clasp will not be able to retain the denture in the mouth. If you do it like this, you can't measure. Okay, you have to lift it up a little bit because you don't see exactly what you're doing there. So we have to find the right position in which we can measure correctly. See? And you see that the left hand is on the table that is moving, and then we will fix it in position. And then we try the next tooth. Is it okay or not? Again, and we can modify slowly, here and there, until we find the right insertion axis, as we call it, the right position of the table, actually of the model in relationship to the vertical axis. You see here, for example, there's very little retentivity, very little undercut, so that's not okay. So we move a little bit the table, we move it a little bit, we change the position, and we try, trial and error, we try until we get the right result. Undercuts, symmetric undercuts on all these 3 teeth. Not that easy. Happily, the technician is the one who does that, so the dentist is happy. Take an impression, send it to the technician, and then that's it. You wait for the denture and you get the money. So this is how you determine the axis. And once you determine that, you fix it for good, and you say, okay, this is the axis. So everything that we will do from now on is in this position of the table, i.e. of the model. And if this is the insertion axis, we can check that we don't have interferences with other teeth when the denture will be inserted, right? Interferences means more undercuts than we need, maybe on other sides of the teeth. Now we want to know the equator, the prosthetic equator. The prosthetic equator means how the vertical axis touches the teeth on all their sides in this position of the model. So now we use the graphite, the marker, this is like a pencil, but okay, this is wrongly placed now. Should not be like this. It has to be absolutely parallel. So this is how you mark the equator. So normally this has to be absolutely vertical, like the other bar, and let it touch the tooth where the equator is. Okay, this is a little bit tilted, so this is not the best way to have it. So there's going to be a supraequatorial and subequatorial zone. The upper one will be, the supraequatorial will be for support, the underequatorial will be for retention. So now the prosthetic equator of those three teeth is drawn, again, in this axis of insertion, right? If you change the axis of insertion, you will have a different equator, obviously. So once this is done, the next thing you do is you place the retentivometer retentiveness bar. Again, this is tilted. It shouldn't be like that. It should be absolutely parallel. This will help us to tell where we have to place the clasp. Where do we have like 0.5 undercut? See? You go close to the tooth, and then when you lift it up, the disc will touch the tooth. Where does the disc touch the tooth? And in that point, you know you have 0. Whatever bar you have, 0.25, 0.5, 0.75. And then you decide what type of clasp will be able to, so to jump over 0.25, 0.5, 0.75, right? So it's a high precision denture. This is important to understand. Here you make a sign, okay? Here you say okay. Here we have 0.25, okay? And here you place the clasp. If we go for 0.25 millimeters, the clasp will sit closer to the equator, obviously. And the denture will go out quicker. It will be less straining for the tooth upon insertion and disinsertion, right? So the 0.5, 0.75, there's going to be more undercuts, so it's going to be more strain for the teeth. So again, we try another one. So that's 0.75. And you see this one tells you, okay, 0.75 is way lower. You can see that. It's clear. Way lower. Because the overjet between the disc and the cylinder is way bigger. Is what? 0.75, as we mentioned before. So normally the dentist will determine where the clasps have to be placed. But most of the times the dentist consults with the technician. You see, but the dentist knows exactly how strong a tooth is and how much strain a tooth can take, and it's not an easy task to decide where you place the clasps. That's the difficult part of this denture, to correctly place the clasps. Once this analysis has been made, so once this is done, you do the project of the framework, and we put wax, so the model will be removed. You put wax on different zones where you don't want the framework to get. Then you will duplicate the model, and before duplicating it, you have to place it back on the table in order to remove the excess wax exactly in the axis of insertion. So if I remove it, how do I know how to place it back? That's a problem. So before removing it, while it's still here, I mark 3 points. In general, it's 2 on the lateral and 1 on the frontal part of the model, where I will draw I will make some notches. So for example, 1 notch here and 2 notches here. So those notches will be absolutely vertical in the insertion axis. So then I can remove the model. I do the project. The screw of the table is fixed in the same place. And then I place this back here. And I will try to fix the model exactly according to the signs that were made before. See? So you imagine that this is the same model actually. And I will bring this in such a position so as to bring the analyzing bar in the correct relationship with the 3 notches that I've created. And now I can bring that scalpel-like accessory to remove the wax at 0 degrees if I want. So this is what demonstrator is doing now. See, this is now correctly positioned, absolutely in axis with the vertical axis of the parallelometer. So slowly I come here, and you see I can remove this at 0 degrees should I want to do that. So this is the last thing that we do on the parallelometer. Then we duplicate this, and on this duplicate model we create the final framework.